So today I'd like to do a little presentation that is off the track of my Curvature amateur string of movies, and it's kind of to confirm or to justify a bit my videos that we do see curvature out in this world over water, as I demonstrated many times throughout my own videos. And I also like to say that my videos also prove that the curvature that we see doesn't make up for the globe curvature that astronomers or NASA or even Google say that we live on. So do we live on a globe that's spinning in space, in the vacuum of space, as the solar system is moving along? Do we live on a globe? On a ball? I don't think so. Flat earthers have demonstrated many reasons to understand, or to believe if you want to be believing, mostly to understand that our Earth is not a ball spinning in space. And if you watch my videos, you'll see that in far distance, we do see images pop up over the water. They don't pop up, they are there already. We just have to look at them with the right tool. The naked eye is good to have. A good clear eye, good eyesight is always an asset in a healthy human body, healthy mind. But it's good to have an extra tool like a telescope. Or for instance, I went out and I bought myself a Nikon P900. If you want a better camera than that, there's also the Nikon P1000. Anyway, so people could look at my videos and say, oh, we see images over the water on our globe, even though our math shows us that we were not supposed to see anything over that water, but we do see something. So it might be caused by refraction. You think so? You think that refraction would bend images that much? Well, if we look in water, everybody knows that water refracts images. Like you look one direction and whoop, it doesn't go that direction. Or let's look at more images. Or if you look at your feet in the bathtub, they're gonna be looking a bit bigger. Or everybody's got ways to experiment with water refraction at home. Okay, even in a lockdown where you can't go anywhere thanks to the politicians that really want to limit your life and take more of your money. Well, you can do experiments at home in the meantime. So we can look at so many different examples of refraction, even through some kind of cube or diamond. So I don't need to show you much more refraction examples, but I just want to show you a bit what Google and Wikipedia guys have to explain to us about refraction. Okay, refraction in physics. The direction of a wave passing from one medium to another. Blah, 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 blah. So you can probably read much better by yourself than I can read to you. Okay, you don't necessarily want to hear me reading. It's gonna hurt your ears. So So we can use some lenses, like glass camera, binoculars, microscopes, human eye. Even in the human eye, there's a refracting crystalline that refracts the light going through your eyes. There's even laws written over refraction. So we get politicians for. So atmospheric refraction is mostly what we're looking for, because we're looking through the air at our images. We're not looking through water at our images. But some people that like to cling on to scientific excuses, they like to say that, well, there's water in the air, there's moisture in the air, that therefore it's going to bend the image. Like the horizon is going to transmit an image over the curvature to show you what's hidden on the other side. Can that really happen? To vary with air temperature and pressure, air density. Okay, so if the air is dense, there's a lot of moisture in the air, then you're going to see more effects of refraction, especially when there's a source of heat below. Okay? Like exhaust, or even looking at pavement here. See a little picture down here. See the asphalt releases a lot of heat, especially with the sun, and the heat in the air, there's so much density and that heat rising that it creates a mirror image. Okay, heat creates that. Heat creates that. Okay? Let's see, another detail I saw I wanted to show you. Even sound could get affected with refraction. Wow, science. Let's do science together. Okay, let's look at something more Wikipedia could offer us, or Google. How does refraction work in water? How does refraction refract light? Well, that's an article. You're not going to learn much from an article. Much better off learning from observation. Come on, don't waste my time. I'm already wasting enough people's time here. Refraction of light and water. Anyway. I saw something last night as I was looking for okay. The phenomenon of refraction is responsible for our ability to focus images with a lens or our eyes. Okay, this is the part I wanted to show you. A number of refraction phenomena can be observed in the atmosphere, but the conditions are quite different because the index of refraction in the air is very small. The refraction in the air is very small. It being a nearly transparent medium. Nearly transparent. So therefore, it doesn't bend the image. The index of refraction of air at standard temperature and pressure, blah blah blah, is 1 point blah 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 compared to exactly 1 for a vacuum. Okay? And you can keep on researching all you want. See, it kind of explains to you that, oh, you see all these phenomena, blah 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 blah. But does anybody really go out in space anymore? Because remember, they went to the moon. They said they went to the moon. They showed you they went to the moon thanks to, what's his name there? Stanley Kubrick. Stanley Kubrick, very good cinema, how do you call that? Guy who makes movie, cinematographer. Okay. And he was even assassinated somewhat, or he died. He died after he made one movie, Eyes Wide Shut, because he was showing too much information in that movie, or the version that he filmed. He was just explaining too much, so he had to die. Mr. Stanley Kubrick. Donald Rumsfeld was the guy who decided to choose Stanley Kubrick to film the moon landing. So they went to the moon for a few years, 1969, 1970, 1971, blah, blah, blah. We're going to the moon, we're back, woohoo, we got our ticket to the moon once more, let's go back to the moon, let's come back on Earth, let's celebrate, let's tell the people how it was. We didn't see any stars. Oh, what did we do up there? We played with some machines. We drove around. We bounced. And while they were filming us, they had to accelerate the movie to make us look like we're going, or decelerate the movie, make us look like we're bouncing slowly. But anyway, enough said about the moon landing. But if you were to go out in space and take a picture of our Earth, okay, if that can even happen, would it look like that? All right, let's get to my point here. So I want to show you a few clips that I took when I went on vacation in Bridgeport, Connecticut, visiting my in-laws. Because my wife is from there. Actually in Lordship, Connecticut, which is a peninsula off of Bridgeport, Stratford. Okay. And I have a couple of videos that I made that explains what I see in my shots, and also explains that we do have curvature on our Earth, and that it is not nearly come close to the number that that Google and all the people that are authorities of our Earth dimensions, they show us it's so far off of that mark. So please watch my videos if you're interested in learning about what could be the shape of our Earth. What could it be? Because nobody's really been out there. Except for those moonlanders. Okay. So in my shot, my clips I'm gonna show you. I'm just gonna show you 3 different things, and I want to, and those 3 things I went like 4 days in a row on the early mornings, or even sometimes it was in the middle of the day, that I was looking at 3 different things. One is the Northport smokestacks here. You get a little glimpse at those guys. And I'm also looking down that way, the long way of Long Island Sound towards New York City. And I can see something sticking out over the water. You can see that much better in Heads Over Water, my video. And there's also another lighthouse somewhere around here, or it could be here, I'm not too sure, that we're looking at. All to compare the refraction index in the air to show you how refraction acts. Okay? Does it bend images over the water like a conduit? Like a, what do you call that? Micro optic fibers? I don't think so. Alright, so let's go look at clips to show you what I'm talking to you about. Just got a note here somewhere. On paper. Real paper. Where did I put that? Here it is. So that's taken from the seawall in Lordship, Connecticut. I'm going to skip along, not going to show you the whole video, it's a bit too long for your eyes. So let's look at the Northport smokestacks across the water here. And if you noticed, I have a whole video on those guys called Smokestack Attack. You should watch it. If you notice, when you're looking at an image that is affected by refraction, atmospheric refraction in the air, okay? The atmospheric refraction, does it bend the image sideways like we see in water? No, it doesn't do that. You think it makes the image go over the curvature of the earth to come to your eyes? We're going to see that it doesn't really affect it, because we would see the images taller or shorter from one day to another. But it's really hard to measure what is the height of our view. It's kind of an impossible thing to do. Even when you have a measuring tape in your hand and something not very long in front of you, you really have to look on where the tape starts and where you're gonna have your line up with the other edge of what you're measuring. Because if your head is not perfectly lined up with those numbers, you're not gonna have an accurate measurement. So what does refraction do? Well, refraction in the air, okay? What it does is the air is gas. Do you see the air? No, you don't. But you see water. Water is not gas, water is liquid. And the difference between water and air is that water, all the water molecules, they're holding each other's hands. Okay, they're not practicing social distancing. They love one another, they hug one another. They are as tightly bond together as water can be. Okay, so the water is, I wouldn't say solid, but the liquid state is, there's no space in between the water molecules like there is in air. You understand that part? Okay, so in air, the air molecules, they're flying around any direction they want. It's not like in water. Water, they kind of have to follow the current one way or the other. If somebody makes a waves one way, a fish flops its tail the other way. So the water molecules are kind of bound one another, and they kind of have to follow one another like sheep, like people wearing masks. So in the air, it's different. In the air molecules are free. They're not touching one another. They might bounce into one another, but most of the time they're free, especially the water molecules. Water molecules are kind of big in the air, okay? And they're all separated by nitrogen molecules, which make up about 75% of the air mass. Nitrogen molecules, oxygen molecules make up about 20% of the air mass. So a lot of oxygen molecules that are floating between the hydrogen-oxygen combination of water. Okay, so the oxygen in the air is not connected to the oxygen in the water molecules because they're free, they're all bouncing one another. There's also carbon dioxide, carbon monoxide in the air, and also a lot of trace elements that are shot by planes intentionally to shoot aluminum particles, strontium particles, barium particles in the air. Okay, there is an agenda behind that. If you don't believe me, these chemtrails have bad intentions. When you see them flying up in the air, you should ask yourselves questions. Why are they putting that in the air? Is it condensation? When you breathe in the winter, when you see your breath in the winter, does your breath trail follow you for a mile long? Or your breath just dissipates in like a few seconds? It doesn't stay. But chemtrails stay a very long time, and they turn into clouds, and they seed clouds. They make the sky gray for most people. So if you want to have a sunny day, you can't live where they spray chemtrails all the time. But life is not that convenient. So when we look at the air being refracted, you see tiny bunch of little waves on the spot. You see these little waves, they're not bending the image one way or the other. They're not making the towers taller or shorter, not making them wider, narrower. But you see tiny little waves out in the air. And it's not the same as the waves in the water. So the other thing I wanted to show you is out towards New York City. Okay, and you can see that much clearer as I explained very thoroughly in my video Heads Over Water. So as I'm panning out towards New York City. Okay, so we can see out there on that day it wasn't so easy to see anything, was it? Oops. Sorry. Sometimes it's hard to hold the camera, even with a tripod. There's a boat out there. But look at all the little waves in the air. Little waves in the air. Okay, little waves in the air. That is atmospherical refraction. Makes the image a bit more blurred, but it doesn't make the image bigger, doesn't make the image smaller, doesn't make it wider, narrower, just makes little waves in front of it. So on that day, I was looking for something out there. I couldn't see anything sticking out over the water. Because if you look at my video, Heads Over Water, we can see some heads, not human heads, but big square heads. So I didn't see any of those on that shot. That's one thing I wanted to see. I went out there for a reason. So here, we saw the lighthouse. Whoop, too far. Here's one of the things I want to show you. As we're staring at this beautiful building that was built before the reset, you can see the little waves of refraction in front of it, as if it was a flag. The flag is not getting bigger, the flag is not getting smaller, it's not bending sideways, it just wobbles. The air distorts the image. Okay, let me show you next one. And all these videos are all in the same area, taken from the same area. This one was a little bit further on the shore than the seawall. Skip along. I'll show you what I want to show you. Further. Okay, here are the Northport smokestacks again. And that was more in the middle of the day. I think it was even more in the afternoon. So there's more heat in the air. Sorry, just looking at it again. There's more heat in the air. There's probably a little bit more wind too. So you can see the water is moving along with the waves. Okay? And you can see the little waves in the air of the atmospheric refraction. They're moving a little bit more. That's also my camera and me moving my camera. So you see the little waves in the air? You see that? That's atmospheric refraction. You even see the waves of the air with the wind blowing over the surface of the building here. Almost makes it look like there's water flowing on top of there. But it doesn't bend the image. Okay? A little further. So here I'm trying to look over the ocean towards New York City. Trying to find something. Whoop! Then my attention got diverted not by those chicks in bikini, but by this airplane. And I just got my Nikon P900 camera a few days before. Got it through mail. And I was just trying it out. See how good that camera can be. Catching up to this airplane that's flying away from me. It's not an easy thing to do. It's a trick. It's an art. Filming with a camera. Believe it or not. I just want to show you the lighthouse. So that day I couldn't see anything out there. I'm sorry I'm not taking any more time to try to show you, but I wasn't able to see anything. No heads over water. Okay. Now I'll pan out to our lighthouse here again. Zoom in. So you see the little waves. Little waves. That's atmospheric refraction. See, it's a little more intense right now. And bear in mind that all my pictures, there's no heat source coming from under. Like I showed you earlier, the heat coming from the train or the heat of the asphalt that is coming off, reflecting the sunlight's heat. But here, what do we have? On all our images, on all of our shots, we have water beneath our image. So there's no source of heat coming from underneath. It's all in the air. And all these shots here were just around the 4th of July in 2018. Hot days, my kids, all they wanted to do was walk from the swimming pool, grandma's swimming pool, to the beach and back, eating some popsicles and other fruit snacks, keeping themselves cool, no hurry. So you see all that refraction? Okay, these were some. You can see that the air is clear. It's not overcast or anything in my shots, but there's an element in the air that keeps us from seeing what we want to see. All right, skip along here. Yeah. See, if you want to see boots losing their bottom, watch my videos, Ferries No Boots. 12 minutes. Okay, here we are again, looking at the Northport smokestacks. And again, you can see the atmospheric refraction waving around. It's waving and waving. See, it bends the image, but how much of the image, see this chimney, you could say, what, 60 feet wide, and the image, it goes back and forth, maybe 5 feet wide, at 20 miles away, but it doesn't make it bigger, doesn't make it smaller, doesn't bend it sideways. Skip along a little bit. A bit further. Okay. So here you can see all that in my video, heads over water, is this building here. What? What? Okay, this is the water here, the Long Island Sound, looking towards New York City. And I see a clear view of a skyscraper. Is that a skyscraper or not? And look at the index of refraction. Barely existing. So there's no refraction so much. You can see it over the water. It doesn't seem to be affecting the building that far away so much. The image is still clear. It doesn't seem to be so wavy. Just to show you that I'm not tricking anything. We're still standing at the seawall in Lordship, Connecticut. And I'm looking at over to New York City, 55 plus miles away. I explain all that in my video, Heads Over Water. That we don't live on a globe because we see curvature, and the earth is not flat because we see curvature. Okay. Look at our lighthouse, and built with Antiquitech. So look at the waves. That is atmospheric refraction. But it's clear on that day. It's one of the clearest shots I got. And I'll show you an even clearer one in the next video. 322. Have nothing to do with this number here. Skull and bones. Here are the Northport smokestacks. And look at the water, how clear it is. And that was early in the morning. As soon as I got my butt out of bed, I rushed to the beach with my camera and tripod. Tripod that I borrowed. It's not the one I have right now. So it's a much clearer day. Oops, sorry. Much clearer day. And you see the index of refraction here is even less than the days before. You don't see as many waves in the image because there's less moisture in the air. Okay? So there's less refraction, therefore you can still see the same height of image as we saw on other days, other times of the day, more humidity, more density in the air. All right, let's skip along. Right. So as we're panning over Long Island Sound towards New York City, we see things like that. That looks about the same building as we saw the day before, but under a different light, different angle of light. It's the same height sticking over the water. Okay. And you see those reflecting parts of the skyscrapers here, like glass. The glass on the skyscraper reflecting the morning sunrise. Early morning Manhattan, ocean winds blow off the land. Early morning. You know, that's part of the Genesis song. The Lamb lies down on Broadway. So look here, we have an image that is being reflected by the almost flat water of that calm morning. So the image is doubled. And we can see clear enough an antenna here sticking out, and we can see the details of the buildings clear enough to see that the index of refraction is absolutely minimal on that clear morning. You do see a bit of waves, okay, and the fact that my camera is slightly moving. So you do see a bit of waves in the air, refracted air. Not too far. Here's our lighthouse again. Are you? So here's our lighthouse. And you can see again the mirror image of the water doubling the rocks. And I'm sorry, I didn't take much time during that moment to look at that for long enough, but you can see that there's less waves in the building, less waves of refraction on that clearer morning, and I'm wobbling more, probably I don't know if it's the wind that's making my tripod shake like that, but it's definitely not the refraction making it wobble so much. Okay, one more example. Okay, still at the seawall. Skip ahead. The ferry, you can see the bottom of the ferry here. As I demonstrate in my video, ferries, no boots. A little bit further. So here are the Northport smokestacks. This one a little too fast. Let me turn back up. There they are. So that was the day after, the clearest day, and the weather. Whoops, the weather is not as clear. So you can't see the image as clearly, and with the refraction, the image waves a little bit. And these were all clear looking days. There was no clouds in the sky, no chemtrails that early. And then looking towards New York City, look out for something out there. But I can't see much. It's not clear enough. Not even gonna try that much because it doesn't look like it's worth it. There's our ferry. The ferry is gonna lead us to our lighthouse. If you're patient enough. And just looking at the ferry, you can see a lot of waves in the air from the atmospherical refraction. Without any source of heat coming from underneath. That water, it might be some of the warmest waters in the year. It's more warmer 2 months later in August, but it still doesn't emit the heat that pavement would, or a train fuming diesel exhaust. Here it is, our lighthouse. And look at all the waves from the atmospheric refraction. You can even see the direction of the airflow. It looks like water flowing. So there you go, ladies and gentlemen. That's what atmospheric refraction does. If you want to argue me about my videos, that the image I see is a mirage. Okay? And remember that a mirage in the desert is possible because of the heat from the sand reflected by the sun. Thank you for listening. Aloha.